problems, so you will have to set up that rational equation. I did include these tables to kind of help you out on how to set that up as well. All right, so the weighted average is a method for finding the mean of a set of numbers in which some elements of the set carry more importance or weight than others. Many real-world problems involving mixtures, work, distance, and interest can be solved by using rational equations. Okay, so we are going to set up a rational equation. So example 1 says Jimmy adds a 65% fruit juice solution, okay, to 15 milliliters of a drink that is 10% fruit juice. How much of the 65% fruit juice solution must be added to create a fruit punch that is 35% fruit juice? Okay, so in this table, I have your fruit juice with your percentages and then the total of liquid. Okay, so looking at the original, this one is not part of the original because it's what you're adding in, right? Okay, but he's adding it to 15 milliliters of this drink, so that's part of your original, right? And that original is 10% fruit juice, so that's part of the original. Okay, if I'm adding in, that's part of the added piece. Okay, so our fruit juice for the original is 10% fruit juice of 15 milliliters. Okay, 10%, what is that as a decimal? 0.1. So we have 0.1 of that fruit juice, and that's with 15 milliliters. Okay, so that's times 15 milliliters, because you have 15 milliliters at 10% fruit juice. That was the original. Okay, adding in. We're trying to figure out how many milliliters of this 65% fruit juice to add in. Okay, so again, I need to change that percent to a decimal. Okay, so I need to add in that 65%. But we don't know how many milliliters of that there is. So that would be our variable. Okay, we don't know how many milliliters of that 65% fruit juice solution to add. Okay, now the total at the bottom here is talking about the total milliliters in your solution. So how many milliliters were in the original? 15. Do we know how many milliliters we're adding in? No. Okay, so to get this new one here, I have to take the original and add in, that's why it's added, your new part here. So we have 0.1 times 15 plus 0.65 times x. Okay, same thing with your total. I have to take my original milliliters, add in the new milliliters.
Is that the answer?
No. You're setting up a rational equation. This is to help you figure out what goes in the numerator and denominator of that rational equation. So we're trying to create a 35% fruit juice solution. Okay, so our percentage of fruit juice is equal to our amount of fruit juice over the total solution. Okay, the percent of fruit juice that we want is 35%. How do I write that as a fraction? Fraction. How do I write it as a... Yes. I'm going to keep it as 35 over 100. Okay, so that's your 35% that you're trying to create. Okay, we're trying to create that. That's why this is equal to that 35%. Okay, that's equal to the amount of fruit juice, which we found here. Okay, that new amount. So 0.1 times 15 plus 0.65 times x over your total solution. Okay, your total solution is in milliliters. So over 15 plus x. Okay, so now we have this rational equation that we've already learned how to solve. Okay, you need that LCM of both denominators, right? Okay, well, the LCM is going to be 100 times 15 plus x. Okay, I could factor out 100, but there's not really any point to do that because 15 plus x is already factored, and that's the only part of that one. Okay, so this LCM is what I need to multiply into both of those fractions to get rid of that denominator. Okay, so starting with our first fraction here, we have 35 over 100. We need to multiply that by that LCM. So 100 times 15 plus x. Okay, same thing with this second fraction here. So 0.1 times 15 plus 0.65x over 15 plus x. And again, multiply that by the LCM. Okay, and I am multiplying by the LCM so I can cancel out these denominators. So here I have 100 over 100. And on this one I have 15 plus x over 15 plus x. Okay, so rewriting my problem here, I have 35 times 15 plus x is equal to this 0.1 times 15 plus 0.65x, and that's multiplied by 100. Okay, so I need to distribute. So 35 times 15 is 525. 35 times x is 35x. Okay, distribute your 100 here. So I have 100 times 0.1 times 15, right? We have to multiply all three of those together. That's 150. Plus 0.65 times 100 is 65x. And it's all for x. So minus 35x. Okay, so I have 525 is equal to 150 plus 30x. Subtract 150. And get a decimal. Divide both sides by 30. It's 12.5. So you need to add 12.5 milliliters of fruit juice solution. Questions? Tried to lay it out pretty nicely for you there to help you. You come up with it and tell me then. Okay. We're doing rational equations, so I wanted to set up a rational equation. I set up a rational equation because that's the unit we're in. All right. On the back then, we have a distance problem, okay, a rate problem. So the formula relating distance, rate, and time can also be used to solve rational equations. The most common use is D equals R times T, so distance equals rate times time. However, it can also be represented by rate is equal to distance over time, and time is equal to distance over rate. Okay, so we can also use it this way, right here, where we do have these fractions. So that's what we're going to do in example 2. So the speed of the wind is 20 miles per hour. Okay, if it takes a plane 7 hours to fly 2,368 miles round trip, determine the plane's speed in still air. Okay, so no friction from your air like physics would have. Now, if I'm talking about round trip, right? What is the distance to the place and then the distance back? How do I figure that out? Not times.
Oh, add it?
If this is a round trip,
Oh, wait, add it by itself?
round trip, right? What's the distance there? If I said the distance round trip to Oshkosh and back is 60 miles, it's not. Okay, what is the distance there?
129. Oh,
30. Okay, take half of it if you have a round trip. Okay, divide by 2. I just made it up. Relax. Okay, divide by 2 to get your distance just there and then just there and back. Okay, so that is 1,184. Okay, so in each of these we're trying to find the time. Okay, so the time with the wind and the time against the wind. So since I'm finding time, I need to use this equation right here. Okay, because that one says time equals. And then I can set it up. So my distance for the time with the wind, so my distance to my distance there, okay, that is that 1,184. And again, I'm using distance over rate. Okay, so my distance is 1,184. Okay, that has to go over our rate. Now, our rate is what we're trying to find. Okay, but it told me that the speed of the wind is 20 miles per hour. Okay, so it's kind of pushing you forward more. Okay, so the speed with the wind, I would take that rate at which I was going. So if, say, I was going 60 miles per hour, right? I'd have to add the speed with the wind, so I'd have to add 20 onto that. Okay, so if you're going with the wind, you're adding that wind speed to your rate. Okay, we want to do the same thing with the time against the wind. So we're still looking for time, so we're still using the distance over rate. So if I'm going against the wind now, that's your distance back from where you were. Okay, so our distance back from where we were would still be this 1,184. Okay, what's in the denominator then if you're against the wind? If I'm going against the wind, minus 20. Okay, so you're taking the rate at which you're going and subtracting 20 from it because you're going against that wind. All right, what's the total time it took me to travel round trip? Look in the word problem. 7 hours. Okay, so to find our rate, we're going to add our 2 times together so that it equals our total time. Okay, so add our 2 times equals our total time. So here I would have 1,184 over r plus 20 plus 1,184 over r minus 20. And that has to equal 7. Okay, you're taking your 2 times there and back, add it together to get your total time. Okay, so now that I've set up this rational equation, I can find that LCM of your denominators. Keeping in mind that this 7 is over 1. Okay, it's a whole number, so it's over 1. So what is my LCM for all those denominators? R plus 20 times R minus 20. Kind of. So I want to write it out like this because I have this quantity and this quantity. So this is what I need to multiply into my 3 fractions. Okay, so rewriting my first fraction here, I need to multiply the LCM into that fraction. Okay, same thing with your second fraction. Multiply the LCM there. And then your last one as well. Okay, so now from here I can cancel out in the numerator and denominator. Okay, so in the first fraction I have r plus 20 over r plus 20. Second one, r minus 20. And third one, I can't cancel anything. So rewriting my problem. What? So I have 1,184 times r minus 20. Yep, plus 1,184 times r plus 20 is equal to 7 times both of those quantities. Okay, and I do want to distribute here. So I have 1,184r minus 23,680 plus 1,184r plus 23,680. Okay, so that's equal to, I'm going to FOIL this out. When I FOIL this out, your middle 2 terms cancel because it's a plus and minus. It's a difference of squares. So I end up with r squared minus 400. Okay, looking back at the left-hand side here, these 23,000s will cancel each other out. Okay, so I can add together my like terms here to get 2,368R is equal to 7R squared minus 2,800. Now, if I have an R squared and an R, what do I have to do? I have an R squared and an R. What do I have to do?
Divided by 1. I don't know, square it.
No.
Get rid of the R. Keep it like that.
This is a quadratic.
It's still
You have to get everything on one side of your equation and set it equal to 0.
Put it in the quadratic.
And put it in the quadratic formula. This one doesn't factor. You can put it in the quadratic formula though.
Oh, you don't factor it down, I think?
No. But you could if it was able to factor.
I think there's a bunch of numbers.
So here I would have 7R squared minus 2,368R minus 2,800. And yes, I do need to use the quadratic formula. So quadratic formula. It's the opposite of b, yep, plus or minus square root of b squared minus 4ac, 2a.
Damn.
Hey, can we stop, please? So to find r, I'm going to plug those values in. So we need the opposite of b. So 2,368 plus or minus square root b squared minus 4 times a times c. Oh, that's a negative. All over 2 times a is 7. Okay, now when you do this, you can just plug it into your calculator right away. And since we're trying to find a rate, can your rate be negative? Can your speed be negative? No. So when you plug this in, you just want to add the square root of this quantity, okay, to find that rate, because it can't be a negative rate. So you can try and enter it into your calculator if you have one. Otherwise, you will end up with your rate being 339.5. And that's in miles per hour. Okay, questions on that one? You're just using your, so that this one, we had to find the rate, but it was talking about the time, so that's why I used time is equal to up here in this formula. Okay, and it wanted you to find the time, so that's why I distance over rate. If you were given, or if it was talking about the rate, then I would use distance over the amount of time, okay? Last one I think is the easiest type. So with this one, this says it took Anthony and Travis 6 hours to rake the leaves together last year. Okay, so raking 1 yard of leaves together took 6 hours. The previous year, it took Travis 10 hours to do it alone. How long will it take Anthony if he rakes them by himself this year? So we're talking about how many yards per hour. Okay, so we need this in yards per hour. Okay, so in each of these it's talking about 1 yard. Okay, so they have 1 yard. Okay, we don't know how long it'll take Anthony. Okay, that's what we have to figure out. So we have to figure out how many hours it would take him. So that's your variable. For Travis, he raked 1 yard in 10 hours by himself. And together, they raked 1 yard in 6 hours. Okay, so to get this together, yards per hour, we just have to add their 2 rates together. Okay, so our equation here, I would have Anthony's rate, which is 1 over x, plus Travis's rate, which is 1/10, to get their rate together, which is 1/6. Okay, I need to find the LCM. Okay, so each of my denominators, x factors to just x, 10 factors to 2 times 5, and 6 factors to 2 times 3. Okay, so our LCM, we have a 2 times a 5. I already had a 2, so I don't need another one. But I need a 3, and I need an x. So 30x is going to be your LCM. Now with that 30x, you need to multiply it into each fraction like we've been doing. So with our first fraction, we have 1 over x, multiply by 30x. 1/10, multiply by 30x. And 1/6, multiply by 30x. And again, I multiply by that LCM so that I can cancel out those denominators. So I have x over x. 30 divided by 10 is 3. And 30 divided by 6 is 5. Okay, so here I have 1 times 30. That's 30 plus 3x is equal to 5x. Okay, subtract 3x from both sides and divide by 2. Okay, so I do get x is 15. So it would take Anthony 15 hours by himself. Okay, so again, you're just setting up these different rational equations to solve for that missing variable.